Hi there science students, and welcome to the first video on electrical circuits. There's a few notes that I've just written here that you might want to write down, so if you want to pause the video and write those down, go ahead. I'll just start to explain what we're going to be looking at in this unit. So electrical circuits consist of wires which are usually made of copper, and they're connected to an energy source such as a battery. So, of course, there are all sorts of different, more modern circuits that exist that don't involve copper, and they have all sorts of different materials, but we're just going to concentrate more on the conventional types of circuits that do involve copper wiring. I've just got a representation of a couple of circuits here. I'm going to close this switch and allow that current to flow and do the same on this one. Okay, so we can see that flow of conventional current through these circuits. Now, one thing to note, of course, this is electrons flowing through wire, right? If I switch to electrons, we see that the electrons are actually going in the opposite direction to what we call current. I'll switch back to current here, going that way. Okay, now, it's actually the physical phenomenon that's occurring is that electrons are flowing, and we can watch them there. Now, the reason that we even have this thing called conventional current is that when they were discovering our electricity originally, they didn't even understand that electrons existed or that they were flowing through the circuit. So they thought it was this thing called conventional current, or this thing called current. And that has stuck with us. Okay, so we understand now that it's actually electrons flowing through the circuit, but we still do a lot of calculations that involve this current, which really doesn't exist like that. But anyway, it works for us. So the two circuits we were just looking at are the ones that we need to learn about. On the left here, we've got a battery which is hooked up to two light bulbs. And when this switch is closed here, current will flow through the circuit and light up the light bulbs. Here's a circuit diagram which represents that circuit above, where we can see these two light bulbs here and here. And here's the battery or the cell. And so the current will flow up through the wires, through the light bulbs, lighting them up, and back round. This is what we call a series circuit. Everything is in series with one another. In the one on the right here, we see that things are a bit different. This is what we call a parallel circuit. So in this case, current will flow through the wire and split at this junction. Some will go this way and some will go that way. So on this circuit diagram down below, that's going to look like this. Okay, and then it's going to go through the light bulbs separately and meet up at the next junction and continue through the circuit. All right, so series and parallel circuits act a little bit differently to one another. And we'll cover that in subsequent videos. For the rest of this video, I just want to talk to you about a few different components of circuits. This here is a light bulb. All right, now, on the previous slide, we could see that light bulbs can also be represented like this. There are a few different symbols that are not so much interchangeable, but more that, they're not hard and fast rules about the different picture that you would use to represent that component. So, you'll see different representations in different places, and some are more, older ones that have been replaced more recently with different symbols. So yeah, there's a couple of different ways to represent some of the different components. Here's just a line, that just means wire. So any wires in a circuit are just a straight line. This is a switch that allows us to control whether the current is flowing through the circuit or not. So here I've got a couple of switches. See, I'll just open that switch and I'll open that one. And that breaks the circuit, like a light switch when you turn the lights on and off. I'll put that back on now and allow the current to continue to flow. here is a cell, and here we have two cells. Multiple cells together are called a battery. So they provide an energy source. We have chemical potential energy stored in a battery. Okay, now over here we have the same component. I'll just do that squiggle a bit nicer. There we go. And these are the different ways you could represent a resistor. Right? So you could use a zigzag shape to represent a resistor, or this rectangular box shape. They're both allowed. Okay. What is a resistor? Well, I suppose for now I'll just tell you that it's something that uses energy. So some resistors have a purpose. Most electrical devices that we use are resistors because they use up energy, like a hairdryer, a telephone, all sorts of different electrical devices use energy, and they have a purpose. You guys will use some resistors in your studies when you're building circuits that have no purpose other than to provide resistance and use energy. They don't do anything else, but I suppose they're there for your study purposes, to learn about resistors. So they use up energy. Okay, a couple more symbols, the last two here. This A symbol, that is the representation of an ammeter. And an ammeter measures current. So that flow of electricity through the circuit. That's what an ammeter does. It measures how quickly is the electricity flowing through through a circuit. Last one here, V is a voltmeter. And that measures voltage. Okay, now I'm going to talk to you guys more about these components later on, and we'll start to use these in some different circuits and do some study on those. But for now, go ahead and consult your question sheet and see if you can identify all the different symbols on that sheet.